Welcome to today's GATE video session. I am Kathicka, Assistant Professor from Department of Cyber Security, SA Engineering College. So, we have learnt about many things in this session, in previous session also. In this session, we will learn about classless interdomain routing notations. First of all, what is an IP addressing? IPv4 addressing is nothing but a unique number given to each and every host in a network. Host is nothing but device connected to a network. If it is uniquely identified, then network transaction will be secured. So only IANA is assigning IP addresses to every device connected in a network. A network can be a WAN network, a LAN network, a MAN network, or any other smaller private networks also. But IP address is mandatory for a device to be connected to a network. IP address, so how is the IP address looks like? IP address is nothing but a 32-bit number consisting of 4 octets separated by a period, like this: 128.11.3.31. Each and every block, that is path separated by a period, 4 blocks separated by a period, will be decoded into a binary digit by router. Like this, 128 can be denoted in binary like this as 8 octets. 11 can be denoted as 8 octets like this. 3 can be denoted as octets like this. Similarly, 31 will also have an octet like this. So, totally there will be a 4 8-bit octets in an IP address. Why I am saying 32-bit address is an IPv4 address? Because space given for IPv4 is 32-bit. So, what is the network ID and host ID? Then comes, in this portion, we have seen that 128.11.3.31. This number is conveying us some information. Last bits represents the host bits or host ID. Remaining portions represents the network ID. So, partition between the network ID and host ID is given by a subnet mask. Also, we are what is a network ID? A general idea about network ID is nothing but like a city address. Host address is specific street within that city. For a postman to deliver a mail or a post to a specific house, he first refers to city, then street, then gate number. Likewise, in network address also, we are mentioning the network ID and host ID. Network ID is like city address and a host ID is like specific house within that street and city. So, why here comes the CIDR notation? CIDR notation is nothing but for concealing the network address and revealing it only to the router or the postman who delivers the information. See, A.B.C.D, that is 4 8-bit octets is denoted like this /n. This 4 8-bit octet IP address has some network ID or it points to some network. So, that is represented by /n. /n is nothing but CIDR notation. This notation always starts with prefix length and a slash. After slash, whatever is coming denotes the network ID or network bits. In 192.168.1.0/24 notation is the CIDR notation. First 24 bits are the, it denotes that first 24 bits are the network address. Remaining address will be the host address. Also, we have to look at one thing. If the network address is 24, from the remaining 32-bit address, we can minus and we can subtract and get the host address like this. 32 minus 24 is equal to 8. So in this network, there will be 8 host IDs. That is what is mentioned by the CIDR notation here. Rules for forming CIDR blocks. First rule, all IPs must be contiguous. Contiguous is nothing but continuous. All IPs must be continuous. If they give a range of IP address, all the IP address should be continuous. If they fix, for example, if they fix within 10 and 10 to 20, the 10 to 20 roll number in a class, it shows that the roll number starting from 10, 11, 12, 13, 14 up to 20 is mentioned. Similarly, in network addressing also, the IP block should be continuous. Then only it can be denoted by a CIDR notations. Then block size must be a power of 2, that is 2 power n. It simplifies network division. That is nothing but block size can be in this we got the host bits as 28. Subtracting the network ID 24 from 32 we got 8. This can be expressed as power of 2, no? 2 power 4 is 2 power 3 is 8. 2 power 3 is 8. So block size, that is host size, can be denoted in power of 2, that is 2 power n. First IP of block divisible by block size, that is the third rule. That is nothing but first IP of the block size means first IP address. If I am saying 10 to 20, the first roll number 10. That is what here also. First IP address, that is if I give a range 128 dot something 128.1.2.10, if I mention the first IP address of the block, that should be divisible by the block length. That is nothing but the last least significant bit or the last block should be 0. Always last blocks or the last 2 blocks also. It will vary depending upon the network and the number of hosts connected. I will give an example, you can better understand it. See, if the block size is 2 power 5, then host ID, that is 5 bits will be allocated for host IDs. Then subtracting the 5 from 32, we get 27 bits. 27 bits denotes the network ID and 5 bits denotes the host ID. In a CIDR notation, if /27 is represented, it denotes the network ID. Then 5 bits represents the host ID. But if you apply this to the given IP address, it should always contain least significant bits. That is last 5 bits should be 0. That is what it's mentioned. I'll give a better example. Check whether this range, they have given this range 100.1.2.32 to 100.1.2.47 is a valid IP address block or not. This is the question posed to us. First, we have to check if it is a valid IP block denoted by CIDR notation. Then we should follow check these rules and follow these steps. First, IP address firstly the IP address are contiguous. See, here it is mentioned as 100.1.2.32. Here also 100.1.2.47. The only block that is varying is last block 32, here 47. So 32 to 47 here it is mentioned. So it is continuous. So first condition is satisfied. Second condition, total number of IP address in the block, that is Total number of IP addresses in the block is 47 minus 32 is equal to 16. So 16 IP addresses represented in this range. So this 16 IP address can be denoted in power of 2. 2 power 4 is nothing but 16. So this condition is also satisfied. Third condition, first IP address, that is 100.1.2.32 is denoted like this, 100.1.2. Then this is the binary representation of this digit 32. It shows that 5 bits, last 5 bits are 0. If the last 5 bits are 0, then it shows that least host IDs, it shows this last 5 bits are host IDs, or the host IDs will be 5 for this range. So this is also satisfied. Since all the 3 rules are satisfied, this is a valid IP address denoted by a CIDR notation. Advantages of CIDR notation: efficient IP usage. See, in classful addressing, class A to class E, there will be a fixed IP addresses given within the class range. Suppose if I give 256 if I want to allocate 256 IP addresses, or if I as IANA if I pose as IANA and give us 256 IP address, it shows that class A will always hold this 256 IP address. Given that even if it has a less number of devices. So not calculating the devices, IP addresses are allocated early in classful addressing. In classless addressing, it is flexibly allocated based upon the number of devices connected to one network. So efficient IP usage and flexible allocation. Based on our necessity, we can allocate IP addresses to that network, to that particular network. If CIDR classless interdomain routing notation or CIDR notation is used. Improved routing. See, as a postman, if he knows his street and city address well, he can deliver the message well. So similarly, in CIDR notation also, if IP address can be segregated into network addresses separately and host addresses separately, all the devices connected to the network will be directly identified by that network ID, and based upon the host ID, each and every devices will be uniquely identified. So this is an advantage. So routing is faster. Now if I want to deliver 10 letters to one particular street like Cherry Street, then sending the packets to the Cherry Street is enough. All the 10 letters can be delivered. Similarly, if network address in the sense the network IDs are identified, then the number of hosts connected to that network can be easily identified and the message can be delivered to that host. Lower administrative overhead, easier IP and network management. In this point, I mentioned that if we can segregate the network separately and the devices connected to the network separately, then organization or arranging and managing that network will be easy for the router. So network management also becomes easier. Complexity. It is complex because for an example, if A network has 92 devices connected and B network has 10 devices connected, a router has to form an algorithm and forward the packets based on that network address. So if first I said 256, right? If class A 256 addresses are allocated, whether I have to even if I have to route 10 packets also, I have to give space for 256 and then forward the packets. So in classless interdomain routing, I have to allocate space only for 10 devices and forward packets to that devices. So if this situation is seen in a large scale for 1 lakh or 10 lakh 10 lakh network addresses, it becomes more and more complex for router for separately governing each and every network. So it is complex to implement. Next will be compatibility issues. Already classful addressing is used by some routers. If I forward packet that uses classless addressing with CIDR notation, it cannot recognize it, and implementing algorithms specially for that network is impossible. So there are some bottlenecks in this. So now we can go to the last session, previous gate question session. If in CIDR notation an IP address is written as 172.26.17.1/25, the subnet mask is, they have given some option. Here they are asking for subnet mask. Already I told you, network ID is nothing but each and every group of network connected to one router or one other WAN or MAN network. So to distinguish between these networks, if suppose A person has 10 computers in his house and B person has 2 computers in his house, they are connected to Airtel network or Vodafone network, then A has to be allocated based on the 10 devices, and B has to be allocated some space based upon his requirements. So to distinguish between these two network ID is used. A will be given a unique network ID and B will be given a unique network ID, and within that A's network 10 devices are there. So 10 devices will be given a unique host IDs also. So differentiate between these network IDs and host IDs, subnet mask is used. Here in this problem, 172.26.17.1 is given as the IP address. See, here /25 is given. So /25 is nothing but network address or network ID. See, 25/25. If we subtract this from 32, we get 7. 32 minus 25 is equal to 7. This denotes 7 host bits. 7 host bits. 2 power 7 gives the 2 power 7 will give the host ID for this IP range. So see, already I told you the third point should be the block size should be the first address of the block should be divisible by the block size. So here 1, 2, 3, 4, 5, 6, 7. 7 bits are set to 0 and 8th bit are set to 1. See. So 2 power 7 is nothing but 128. While they ask for subnet mask, all the bits should be 1 except the host bits. So here if we set other from the 4 8-bit octets, if we set 1 8-bit octets as 1, octets is nothing but 8-bit binary number. So all the 8 bits are set to 1, 255. If all the 8 bits are set to 1, it is 255. Here we have to start counting from 2 power 0, 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7. If 2 power 7 is alone set, then it is 128. But so the subnet mask will be 255.255.255.128. Okay, now let's see the second question. Which one of the following CIDR prefix exactly represent the range of IP address 10.12.2.0 to 10.12.3.255? See, here they are asking for network IDs or the /n notation. See, first we have to form a CIDR block or a CIDR notation. First we have to check the first rule, if it is contiguous or not. See here 10.12.2, here 10.12.3, last block is alone varying. Here 0, here it is 255. So if we change if we change this into binary code, then we can keep this 10.12 alone separately and decode this last 2-bit octets like this. 10.12.2.0 can be represented like this. 10.12. Common IDs represents the network IDs, and the least significant bits, which are all 0, represents the host IDs. So here 10.12.2 can be denoted like this. 0, 0, 0, 0, 0, 0, that means nothing but last 2 bits. 0, 1, 2 power 1 is 2. So here it is mentioned like this. Now 3 can be denoted like this. If we compare these two IP addresses, we can come to a conclusion that only the last 8-bit octets, that is 1, 2, 3, 4, 5, 6, 7, 8 are 0 here, and here it is 1, and here it is 0, 0. So last 9 bits are 0 here. What are all the bits 0 here? Last 9 bits are 0. Here it is 1. Here it is 1. So it shows that last 9 bits, what are all the bits that are 0, denotes the host bits. So 9 host bits are denotes the host IDs. So subtracting that 9 from 32, we get 32 minus 9 is equal to 23. So 23 is the network IDs, and 9 represents the host bits, that is 2 power 9 represents the host ID also. So 23 bits denotes the network ID. So we can write this in /23 notation. This is known as CIDR notation. /23 denotes the CIDR notation. / followed by the network ID denotes the CIDR notation. Thank you. We can see further topics in the next GATE video sessions.